I'm very excited to get started here and tell you about how we can make superhumans with technology. I see some of you in the audience making some very dubious looks, not quite buying into this. But I'm telling you it's possible. And why not, right? We're already cybernetic. Uh-oh, my clicker's not working. Uh-oh. Okay, I'm telling you we're cybernetic. Look how cybernetic I am. Ah, there it is. All right, so we're cybernetic already, right? How many of you Googled me before you came in today to hear this talk, right? And over the next few days, you're going to be doing a lot of networking, and you're going to be using LinkedIn to connect to your fellow participants here. In fact, the other day, this doesn't work at all. The other day, I watched this YouTube video to figure out how to tie my husband's bow tie before going to a wedding. I felt a lot like Trinity from The Matrix, right? I watched this video, suddenly I knew how to do it. But it didn't exactly feel, now it's going by itself. I didn't feel cybernetic. It didn't feel like I had this magical power. It felt like I was using technology. So I think it's fair to say that we are cybernetic, but we have this like lead weight on our brain holding us back. Let me give you an example. Let's talk about another cybernetic ability. Really need a new clicker. GPS. So GPS. This is a recent screen capture I did trying to drive around England using the GPS in my car. And looking at it on this screen, although pixelated, it's easy to kind of read all this stuff. We have plenty of time, and making you sit here, look at it, you can pick up all the details. But now imagine driving really fast down a road in England on the wrong side of the road, shifting with your wrong hand, right? As well as suddenly coming upon this intersection. An intersection, a roundabout, that I have never encountered. In San Francisco, California, we don't really have these things. So I was really already confused as to what to do. I didn't understand the map markings. I didn't understand the intersection itself. I ended up driving around this intersection 3 or 4 times, screaming at the top of my lungs about Big Ben and Parliament, before I finally figured out the right way to do it. It was overtaxing my brain. It was stressing me out and making it very dangerous for me to drive in that situation. And that's what I mean by a lead weight. It just takes so much thought to operate these pieces of technology. The problem is that human beings have very limited working memory. That's your task space or your short-term memory, and that's the memory that your brain uses to hold all the information relative to what you're trying to accomplish, okay? Let me give you an example of this. So I know you've had this experience. It happens to me all the time. I'm sitting on a couch. I need to go into my room to get something. I get up, I walk into that room, and I immediately forget what I came in that room for. Now, I assure you, this is not happening just because you're getting older. You are getting older, but it's not that problem. It's really a problem of our minds. Our minds are incredibly efficient at managing that working memory. And every time that we introduce a new context, your brain says, you know what, I don't need this information. This was relative to that other context, not this one, so it drops it all out. And that creates an interruption. It's an interruption in your thinking, and it can cost anywhere from 0.3 seconds to 30 minutes to get back to whatever task you are trying to do because of that little short circuit. Now, our interface, oh boy, this is fun. Our interface is a UI interruption. UI is an interruption nightmare, right? Just looking at this clicker problem that I'm having here, it's causing me to rethink everything. But also, our UI, basically every time that we ask the user to look at the user interface or to interact, to load some other piece of paper onto that magic piece of paper, we're creating a doorway that they have to walk through. It's a whole new context. It's a context switch. And it takes anywhere from 0.3 seconds to 30 minutes to get back to task. Now, in an hour of working on this presentation, you're watching a video of it now, I did 267 task switch in 1 hour. That's 267 chances to be completely interrupted and distracted from my task, as I clearly got here looking at Facebook, right? So it's constantly creating these problems for us. Now, that's about 3.5 hours wasted in an 8-hour workday. That's really costly. And it definitely does not, okay, does not feel like magic, and neither does this clicker. Yes, magic is skipping the right steps. So let's think about it if I was a magician standing up here, and coming out, I put my hat on the table and pulled out a rabbit and shoved it in the hat, and then pulled it out again. You wouldn't be like, oh, magic. You'd be like, yeah, okay, you put it in the hat and then you took it out. Big deal. Magic is skipping the right steps to create an illusion of simplicity where, in fact, complexity exists. And we can make magic with our technology if we follow 2 simple steps. First, we need to teach tech context. Context is incredibly important. Like I said, every time you walk through that door, that context switch, it's confusing. And so if we can teach technology to recognize what context I am in, I am working on this application, I am trying to use the clicker, right? Then it will be more efficient. So let's take a look. When I worked at HoloLens for Microsoft, I strapped GoPros to a bunch of my friends' heads and made them walk around and record every single thing. One thing was really interesting, what they decided to film versus keep private. But even that became incredibly predictable. Because the fact of the matter is, you're boring. Every single one of you are boring. You do the same things at the same time, in the same places, with the same people. In fact, we've known for years that within a given context and a given device, we can guess within 2 to 3 things what you're most likely to be doing with that piece of equipment. But for this whole time, technology has been really context deaf. It doesn't really seem to understand what's happening. It shows alerts in the middle of my talk, right? I'm going to admit something to you. Every time I go to sleep at night, I like to watch really cozy British mysteries like Agatha Christie or Father Brown. I know it's embarrassing. But this is the feed that I get on my Netflix accounts. I'm always watching it on Netflix. But here's what it's recommending to me. It's recommending to me a lot of adventure shows, some crazy dramas, action and adventures, all the things that are the complete opposite of cozy British mysteries when I'm trying to go to sleep. It doesn't understand the context. So even though I have an algorithm that works for me and a few million people like me, it doesn't work for me personally. But technology is finally learning context, right? We have all kinds of technologies that are coming to bear. We have connected homes and natural language processing, which, by the way, is getting as good as human language processing. We have augmented reality that's going to see every single thing we see. And then we have this major leap forward in machine vision. Now machines can detect better than humans what's happening in an image photograph. Humans are at like 95%, and it's at 98%. So it's better than humans. We also have portable computing going with us everywhere, and sensors on every little thing in the world. So finally, technology can understand context. And because of that, technology can also start to speak. Wow, that's a pain. Tech. Tech can speak tech, right? So it can start to anticipate our needs and take action on our behalf before we even realize, right? Just like the Nest thermostat. It watches you in the way that you interact with your spaces and how many times you set it. So it knows, okay, she's in this room at this time of day, it's this temperature outside, and she always sets it to this. So rather than me having to go in and set it, it just automatically sets it for me. We see the same thing with self-driving cars and all kinds of other technology that can start to anticipate us and do things on our behalf, thereby eliminating a number of the steps that I was talking about, those interruptions. It cuts it down by at least half, which is great, but doesn't go far enough. To make magic, we need another step. Right. Really right. Okay, yes, thank you. We need to teach it physical and cognitive ergonomics. Let me explain what I mean by that. I'm sure a lot of you are familiar with physical ergonomics. Yeah. Physical ergonomics are basically physical affordances that help human beings be more as effective as possible in a given system. right? So for example, the placement of your computer screen and the height of your chair, right? That's a common ergonomic thing, as well as things like the shape of the handle on a trowel that you use to dig in the dirt, right? If you have it in the wrong way, it can be very ineffective. But when you put it in another way, it makes it super easy to do those tasks. Well, cognitive ergonomics do the exact same thing. Oh my gosh. Cognitive ergonomics basically create affordances for the human mind to operate within a technological system, right? So just in the same way that physical affordance or physical ergonomics basically makes the system adapt to human functioning, the same is true for cognitive ergonomics. They make the system function to the way that our brains work and operate in the real world. And in essence, when the two of these things work together, we make technology work as easy, or operate technology as easy as operating our own minds and bodies. And this is a major leap forward in the human-machine interface. This means that I can operate technology at the speed of thought. And that's a huge breakthrough. It takes so many of those steps that I was talking about and shrinks them to almost zero. Okay? And when this happens, we get superpowers. Let me give you an example. This is the NASA and GM RoboGlove. Okay? It's based on that robot that you see there on the right. Okay, that was it's called Robonaut 2, and it was the first humanoid robot in space. Really important about that was the hand that they had created on this robot. It was really, really strong and effective. The issue is that it was a bot over there. And to control it, you needed controllers and code to make that happen. So what GM and NASA did is they took that robot hand and they created it into a glove that we put over our actual hand. Now I can control the robot hand just by moving my hand. And when that happens, we get superpowers. Now, because I have a robot hand over my hand and that it's easy to operate as just moving my hand, suddenly I get the benefit that I can lift 15 to 20 pounds of something with the amount of effort that takes about 5 to 10. So with the effort of lifting 5 to 10 pounds, I'm lifting 15 to 20. That's a massive breakthrough, right? It's more than doubling my ability to lift things. So let's look at the way that, especially in AR and VR, mixed realities, we start to look at visual and spatial cognitive ergonomics. Now, we all know that mixed reality basically communicates right to your visual cortex, right? It provides all your visual sensory intake. And that visual cortex is really important. Your vision is your primary sense, and you use it to triangulate all your other senses. In addition to that, it's complicit in 85% of your innate cognitive abilities, especially things having to do with your spatial cortex or spatial cognition. Now, your spatial cortex is so important because it's a large part of your brain. Take your hand and put it on the back of your head. Nobody's going to laugh at you, I promise. Do it. It's a large part of your brain, right? It's a huge part of it. And it's complicit on both sides of your brain, not just one side or the other. And over 200,000 years, we have evolved to use that spatial cortex to offload all kinds of things from our working memory into our innate cognitive abilities. Spatial cognition allows us to do magical things. For example, it allows us to tell the difference between two objects just based on their size and dimension. It allows us to understand massive amounts of content just based on their spatial semantics, right? So like an alphabetical list, or a calendar, or a timeline, or even groupings of sticky notes on a whiteboard, right? It's also really important to external memory. I am terrible at losing my keys, but if I put them in my key box next to the door, I always remember where they are. And the next time if I have something I have to take with me next time I leave my house, I put it next to my key box, because then I'm more likely to see it and remember to grab it. This is external memory. But maybe more important in the context of what I'm talking about here is multitasking. Space helps us in multitasking. So, our existing UI has no space, right? It's just a magical flat piece of paper. There's a very 2D element to it. But we have known since 1993 that adding space to computing actually improves your productivity upwards of 40%. So what I mean by that is if I'm working on my presentation and I use 3 monitors, one for my presentation, one for my emails, one for the content that I'm referencing, I actually improve productivity 40% because I eliminate all those interactions with the UI simply by turning my head. Okay? That little simple trick does that much of a benefit. So imagine what happens when we look at mixed reality. Mixed reality adds both context and space to computing. So now we have that special magic sauce that I was talking about. We're teaching it context and we're giving it some spatial, physical and cognitive ergonomics, right? So we become super efficient, as you see here in this video, right? This guy is seeing on the floor, in the space, exactly where he needs to turn. And when he's doing his task, the system is recognizing it automatically, thereby shortcutting a number of steps in the process. So they become super efficient. It's why you fall over, too. Your brain so completely believes the visual and the spatial stuff that you actually create false spatial memories in there. Little kids create fully false memories in VR, right? So our brain believes it so much that it can't differentiate between what we're seeing on the screen and what's happening in the real world. And that's why this happens, right? We play this game at Singularity University where we give them this demo of the roller coaster, and I always tell people to sit down, and they never do, and they always fall over. It never fails. But this magic is also what gives us superhuman healing factor, right? Let me give you an example. Burn patients, they experience burns that have burns over more than 60% of their body. They experience pain 24 hours a day, 7 days a week. It's so excruciating that morphine only reduces the pain by about 20%, which is really nothing. You might as well put an ice pack on there. But researchers at the Washington's HIT lab decided to do a little experiment. They created this icy wonderland here, where burn patients would throw snowballs at poor little snowmen and penguins, and also see this icy wonderland. Now, remember that I told you that your visual sense is your dominant sense. It's the one that colors all your other senses. Well, what happens here is that they see the icy, and they translate the burning into this kind of icy. So they trick the mind into thinking that actually they're experiencing some freezing. In addition, because the VR experience is so immersive, it distracts the mind from what's happening on the physical outside of the body. And so this VR experience improves pain by 60% without morphine. 20% with morphine, VR, 60%. Okay, that's the human mind actually curing itself of pain in that moment. Let's take it one step further. This is diplopia, developed by my friend here, James Blaha. Now, he had a lazy eye, or an eye that wasn't really focusing in the real world. So even in the real world, he only had 2D vision. It used to be that they thought that after age 12, your neuroplasticity, or your brain's ability to rewire itself, ended. After that, you were pretty much set with the brain that you had. That's kind of how we thought about things. Until recently when we started playing with VR. Now, what James did was he decided to send a different visual signal to the active eye and to the non-active eye. And when he did this, what happened is that the brain started to pay attention to the data coming from that non-active eye. And it started to reintegrate that eye into its visual system. And he fixed his lazy eye. So now, even in the real world, he can see in 3D for the first time in his life. It rehydrated that neuroplasticity. The brain fixed itself without pharmaceuticals and without surgery. Let's take it another step further. This one blows my mind. This is by researchers at Duke University. It's called the Walk Again Project. What they did was they started with this VR, and they trained these paraplegics, people who could no longer move their legs, to control an avatar in AR. And then they graduated to this suit. And what happened was tremendous. Because the eyes were telling the legs that they were moving, and they were activating that part of their brain at the same time, the brain finally created a new neural pathway. This is that person, and they're moving their leg on their own. This guy was paraplegic, and he could move his leg on his own after this therapy. In fact, all 8 patients in this study were able to do so. Now, that's not somebody going in with surgery and fixing things. That's not some sort of pharmaceutical solution. That's superhuman healing factor. The body healed itself. It created a new neural pathway between the brain and the legs that had been lost in an accident. Now, using this methodology, we can create whole leagues of superhumans. What kind of superpower do you want, right? We can make anything that you want. You want Spidey sense? We can give you Spidey sense. We can use a Daiquiri helmet that's got it's an AR helmet that has infrared right in there, so you can see in infrared. We have the Lockheed Martin F-35 fighter jet helmet that basically erases the plane so that the pilot basically can see in 360 degrees without anything blocking their view. But even further, we can put a sonar onto your hand, and you can feel the environment. This is Tacit by Steve Hofer, a friend of mine, and it was basically a replacement for the white cane that blind people use, and it provides better fidelity. In fact, we can make blind people taste sight by using a camera, an outward-facing camera, and a little vibrotactile pad put onto their tongues. It translates the visual images into this tactile taste sensation on their tongue. So now they can taste sight. You want supercognition like I did? You want to be Trinity? We can make that happen, right? We can just use Striver here to train your muscle memory in the environment. And then we can use things like Google Translate to automatically translate what you're seeing. And trust me, I've used this a lot around Germany, and it's been very helpful. I can also put a chip into my brain called Kernel that will allow me to connect to data just by thinking. I could ask a question, and Google can answer it right into my brain. But even if you don't want to put a chip in your brain, you can use something like Augmenta that's watching this guy try to solve this Rubik's Cube. And unlike me, who has to take it apart and put it back together, it shows you exactly what to do right then and there. So it's instantly augmenting your cognition. Heck, we can have superhuman strength. We use that glove that I showed you, along with BrainGate 2, which is a neural implant that allows you to move objects with your brain as easily as you move objects with your arm, right? And suddenly we have all kinds of superpowers. The fact of the matter is, we're exiting this era of supercomputers where we train humans what to do in what order, and we give them tons of steps in between intent and task. We are now entering the era of superhumans. The only question is, what do you want your superpower to be? Because it's all possible. It's right there. Thank you.